Hello everyone, and welcome to another GIS mathematics tutorial video. And in this video series, I want to take what we've talked about so far and tie it into some sort of GIS explicit examples. And I think one of the most important things to do is to talk about how we can calculate the area of a polygon. The area of a polygon. Right? And so, we kind of know how to calculate the distance between two lines. So calculating the distance of a line, obviously that's an important thing in GIS, but it's sort of a direct translation from the pure math to the GIS application. But calculating the area of a polygon is something that we haven't covered yet. And I think it's worth talking about in a specific GIS context. So what I want to do is I want to start off with talking about the area of a triangle, and I want to work through how you would calculate it normally, and then how we can calculate it given just the coordinates, which is what you would have in a GIS framework. Right? And so what I have here is I have a triangle, right, with 3 points, A, B, and C, that designate a triangle. And I've sort of gone ahead and I've saved us some time here. I've specified that this is a right triangle, right, that these two lines are perpendicular. If you don't believe me, you can calculate it out for yourself. But basically, these two lines are perpendicular. And we know, again, I calculated the lengths in advance to save us a little bit of time, right, that these two lines are 2.4 and 2.4. Right, so we know from high school geometry that the area of a triangle is 1/2 base times height. Right, 1/2 base times height. This is the geometry definition for the area of a triangle. Right, and so we know that in this particular case, right, we know that, right, we know that this right here, actually let's make that a little bit thicker so you can actually see it. Right, we know that this right here, right, this is our base. Right, so in this case, our base is going to be equal to the length of line segment BC, right, the length of line segment BC, and we know that that is 2.24. And then we know that our height in this example is going to be this distance right here, right, this right here, right, this is our height, H-I-G-H-T, which means that this is going to be the length of line segment AC, and we know that in this particular instance, right, that is also approximately 2.24. Okay, so what we can do now is we can take these values and we can calculate 1/2 times 2.24 times 2.24. Let's make these into those so there's no confusion about decimal points or anything like that. Right, and if you do that math, you will get that the area is going to be approximately equal to 2.5 units squared. Right? We don't know what the units are, but we're just going to make U for units squared. Okay. So this is the area that we sort of are aiming for. This is the basic definition of area of a triangle using geometry and some distance calculations and that kind of thing. Now, I'm going to sort of explain another approach, and you can sort of just believe me when I say that it is derived from this equation, 1/2 base times height. If you want to see the sort of steps that are involved in that derivation, they are found in the chapter 4 of the Mathematical Techniques in GIS 2nd edition by Peter Dale. He walks through the algebra of deriving the equation I'm about to tell you from this equation right here. Right. So the other way that we can approach this, so this is the old way. Let's go ahead and write that. This is the old way. Right? And you can imagine how this would be difficult for a computer to do, right? Because the computer would have to know what the base is, the computer would have to know what the height is, right? You have 3 points. Figuring out this equation would be very difficult for a computer, right? The new way, right, this way is going to be very easy for a computer to do, right? And this new way is 1/2 times the absolute value of x sub a, which is the x coordinate of the point A, times y sub b, which is the y coordinate of the B point, plus, we're going to move everything down 1, and we're going to go x sub b, right, because that's the next point in the diagram, times y sub c, right? So we're shifting everything down. We started with x sub a, then we went to x sub b, right? And now we're going to add in x sub c, and then we're going to shift around, and this is going to be y sub a. Okay, so now what we do, because we've hit the end of the line here, right? There's no d in this shape. We now do a minus, and then we flip it, and now we do y sub a, which is the y coordinate of the A point, times x sub b, which is now the x coordinate of the B point. Oh, sorry, that should be plus, not times. Wait, that should be times. Sorry, that should be times. Plus, now we're going to move down again, and we're going to do y sub b times x sub c. Then we're going to move down one more time, plus y sub c. And then because we've hit the end of that, we're going to shift back and we're going to go to x sub a, absolute value. Okay, so I know this is kind of an obnoxious string here, but this is the way that your computer would calculate the area of a polygon. So let's just go ahead and quickly prove that this works. So x sub a is -1, y sub b is 3, right? -1 and 3, plus x sub b is 2, y sub c is 1 again, right? The x coordinate of b, the y coordinate of c, plus, let's put some multiplication symbols there, plus x coordinate of c is 1, and the y coordinate of a is 2. All right, so let's do the multiplication really quick here. We have -3 plus 2 plus 2. We do the addition. That's -3 plus 2 is -1, plus 2 is +1. So this is going to be a +1 over here. Let's do this side. So now we're going to do y sub a, which is 2, times the b x coordinate of b, which is also 2. All right. We're going to do the y coordinate of b, which is 3, times the x coordinate of c, which is 1. And then we're going to add the y coordinate of c, which is 1, times the x coordinate of a, which is -1. So let's go ahead and do the multiplication down here. So that's going to be 4 plus 3 plus -1. So 4 plus 3 is 7, plus -1 is going to be 6. Let's go ahead and scroll down just a little bit here. And we're going to have 1 minus 6 is going to be equal to -5. Right, the absolute value of -5 is 5, because again, in the absolute value, if it's negative, it becomes positive. All right, so we have 5 divided by 2, right? Because this whole thing here is divided by 2. That's going to give us 2.5, which if we go back up here, right, this was approximate, and that's because all of these were rounded. The actual area of this triangle is 2.5 units. 2.5 units squared. All right, so this right here is the way that your computer would calculate the area of this polygon. And in the next video, I'm going to go through an example using a square just to prove to you that this equation here can extend to any number of sides. So we can do squares, pentagons, hexagons, convex shapes, you name it. As long as you have a closed loop and your points are in order, right? A to B to C to D to A. As long as they're in a closed order, you will end up getting the right area. Hopefully this made sense. If it didn't, I encourage you to pause the video, go back, rewatch the parts you're confused about, and as always, please reach out. Thank you.